Welcome back. In previous lecture, we continued with hydraulic samples and we talked about double acting hydraulic cylinders. We understood how the extension and retraction strokes works. We were also able to calculate the force during extension and during retraction. Also, we calculated the velocity of piston during extension and during retraction. Now we came to the last lecture in this section, and in this lecture we'll demonstrate our understanding in how to read a complicated hydraulic circuit or sketch. So let's start and we'll see this example. From the first glance, such a schematic looks complicated, and any hydraulic circuit, when you read the sketch, you will feel it is complicated, so don't panic. The easier way to understand any hydraulic sketch or system is to break down the circuit into individual components, which allow you for an easier understanding. So let's apply this here. The first item we are seeing here is the hydraulic reservoir or oil tank. And from this sample, we can easily realize that it has a breather and it is not pressurized. Not pressurized because it is an open rectangle. For the pressurized tank, it will be closed rectangle. After that, we have the hydraulic pump with motor. Here is the motor and hydraulic pump. And from these samples, we can identify that it is a single rotation because single arrow. So it supplies oils in only one direction. And most of the cases, this will be a single fixed displacement pump. After that, the next element will be filter with a bypass valve. Here is the sample of the filter, and this is a bypass valve. And this bypass valve will open when the filter is blocked or oil is too cold. The next item will be pressure relief valve, and when the oil pressure exceeds the set value of this valve, then the pressure relief valve will open and the remaining or excess oil will be returning to the tank. Then we have a DCV or directional control valve, and if we can, let me zoom it. If we can see this valve here, we can see it has 3 envelopes. That means it will have 3 positions, and mentioned here tilt, hold and dump for the operation of the actuator. Then it is a 6-way valve. 6 ways because we have here 1, 2, 3, 4, 5, 6 ports. Then a check valve to stop work equipment from dropping when the spool is just opening, and excess pressure or excess oil will go back to the tank. Then we have a safety suction valve. This valve is a combination of a pressure safety valve and suction valve. The pressure safety valve will release the positive pressure back to the tank, and the suction valve will allow oil to enter the circuit from the tank when a negative pressure is presented. Then we have a double acting cylinder used to do the operation, whether dump, tilt or hold. And why it is double acting? Because we have 2 ports here, port 1, port 2. Then the next item will be again a directional control valve, and in this case we have here four positions because we have 4 envelopes, and 4-way because and 6-way because we have 6 ports, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it is a 5-way, 4-position directional control valve, controlling the actuator to either raise, hold, lower or float. And then a check valve to ensure excess return to the tank. Again, a suction valve to avoid generating negative pressure during the actuator's movement. And the final item here is a double acting cylinder. So this circuit will be composed of hydraulic reservoir, hydraulic pump with motor, filter element with bypass, relief valve, control valve, safety suction valve, a double acting cylinder, control valve, suction valve, and double acting cylinder. We came to the end of this lecture and this section. Thank you so much and see you in next section, section number 3, where we'll be going to each component in detail to understand the main function and the various type of this component. Thank you.